Thanks for attending the ARM Dev Summit. I'm Jason Andrews, and today I'm going to talk to you about Windows on ARM for software developers. So today we're going to cover some background about what is Windows 10 on ARM, and then I'm going to talk a little bit about development tools that you can use for software development. We're going to cover Visual Studio Code on ARM64. Then we're going to talk about the Windows Subsystem for Linux, also known as WSL2. And then we're going to talk about the Build Once, Run Anywhere feature of containers and introduce Docker into our software development environment. And then I'll wrap up at the end with some more tips. Okay, so a little bit of background about Windows 10 on ARM if you're not familiar. What we're talking about here is laptops and tablets which are now available on the market which contain ARM processors. So all of the machines have some common characteristics. The first one is that they're always connected. They come with 4G LTE and 5G connectivity, so you can connect from anywhere. They also have very long battery life. So we're talking about all-day battery life is typically what you'll see in the marketing material. So you can just plug it in at the end of the day or maybe for a few minutes during lunch while you use the machine. Also, very thin, lightweight, and fanless. So definitely no hot air or fans coming out the side of the machines. And of course, they all run the Windows 10 operating system. So Windows 10 on ARM is developed in partnership with Qualcomm. And some of the machines that you'll see in the market today are the Microsoft Surface Pro X, which is built on the Microsoft SQ1 processor. You also see a number of machines from Samsung and Lenovo, which are based on the Qualcomm Snapdragon 8CX compute platform. So all of these have 64-bit ARMv8 architecture, and they're going to be 8-core machines that you're using. So the performance is very good that way. So what I want to do now is talk a little bit about the software developer tools which are available and how we can use that in our daily software development work. So the first thing we're going to talk about is Visual Studio Code. So VS Code, as it's known, is available as a native application on ARM64. This is a very popular development environment for software engineers. Typically, I run the Insider version, so that's kind of the latest and greatest version. So that one starts a little bit different than the regular VS Code. So you type code-insiders to start it. And then I've included a little screenshot on the bottom right corner of the slide there, which is the help about, and shows that this is indeed Windows 10 on ARM. You'll see the ARM64 in the bottom there. So one thing I would like to note is that some of the extensions for VS Code on ARM haven't always worked. But as of this week, we have some good news to report on that. One of the most popular extensions for C and C++ has just reached version 1.0 and fully supports the ARM architecture. So over time, the extensions are migrating to ARM, and that C++ extension is a big one. So we're really happy to have that just came available this week. Next thing we're going to talk about is the Windows Subsystem for Linux. So there has been Windows Subsystem for Linux support in Windows 10 for some time. The implementation of that is now known as WSL1, which was a system called Translation Layer, where Linux applications would make Linux system calls and WSL1 would translate those into Windows kernel calls. But more recently, we have an all-new implementation of WSL, which is now known as WSL2. And that includes a full Linux kernel, as well as the Linux distribution that you're running, working with a hypervisor. So the great news here is that you get a real ARM Linux kernel, and you really overcome all of the previous limitations of WSL1, which is primarily around the file I/O performance. So WSL1, while it did work fine, it wasn't fast enough really in terms of the file I/O. So now with WSL2, we get a full ARM kernel, and we can run containers for application development. We can support any number of different Linux distributions. So along with VS Code, this is going to serve as really the basis for the software developer experience with Windows 10 on ARM. So how to install WSL2? First requirement is we want to have a fairly recent version of Windows, which is going to support WSL2. If you have a Windows 10 on ARM machine, most likely you already have that, as all the machines are fairly new. So the way that you would enable WSL2 is by going into the Windows turn features on or off area. And there's two features that need to be turned on. One is the virtual machine platform, and the other one is a little bit farther down, the Windows subsystem for Linux. So if you turn both of those on and then click OK, restart the machine, some software will get installed, and you'll be up and running with WSL2. It's pretty straightforward. The other point I'd like to make is that you want to set the default version of WSL to be 2. So actually WSL1 still does work in Windows, and so we want to make sure that all of our new operating systems that we install, any Linux distributions we install, would be working with WSL2. So I put a command there for you to see. You can type WSL --set default version to 2, and then from then on it will always default to WSL2. So that's good to do. So once you have WSL2 installed, you can go to the Microsoft Store. You can install any Linux distributions which are available there. That's probably your quickest path to get up and running. So you'll find distributions for Ubuntu. You'll find numerous other ones in terms of Debian or even Alpine, different things. If you search around in the store, I'd recommend just look for Linux and see what kind of distributions are there. The other thing we have, which is fairly new in Windows 10, is a new Windows terminal. The neat thing about the terminal here is that it can support tabs which have different command prompts in each one of the tabs. So with the new terminal, you can have the traditional commands, or CMD maybe for short. You can have PowerShell, and then you can have tabs with any of your Linux distributions which are there. The new terminal is available from the Microsoft Store. If you go there and search for Windows Terminal, you'll find it. I put a terminal here with one of the tabs with one of my WSL2 Linux distributions, and then you see I just ran NeoFetch. And indeed, you can see it's Ubuntu 2004, and it's running on Windows 10 with the ARC64 architecture. So you can see it looks and feels just like a real Linux installation for the ARM architecture, and I'm running it right on Windows 10. So if you're interested in the terminal itself, I put the link to the GitHub project. You can go have a look at that and see what the latest activity is and keep up on all the developments with the new Windows terminal. Okay, once we have that, then the next thing for software development we're going to talk about is Docker. So the neat thing about Docker is it runs great on WSL2, and it looks and feels just like any other Linux distribution. So the quickest way to do that is by following the short instructions for Docker installation. So we do a curl to get.docker.com. That will download a shell script, and then we can run that shell script, and it will go through all the needed steps to install Docker. Usually recommend is one more command, the user mod command, which will add your user ID to the Docker group. This enables you to run Docker without any sudo or root privileges. So you can do that, and then your user ID will be added to the Docker group. The one thing to note about WSL2 is that the Docker daemon does not start automatically. So I show a command there to run the Docker start command, and that will launch the Docker daemon, which will enable you to go ahead and start using Docker commands. So once you start the daemon, you can do things like Docker run hello world, and you'll see the output right there in your terminal, and you'll be up and running with Docker. Now, the one thing I did want to note is there's no Docker desktop for ARM64. So anybody who's familiar with Docker desktop, it's a product for Windows and Mac, which makes Docker a little bit easier to use for Windows and Mac machines. And it doesn't exist yet for Windows on ARM. So there is a place in GitHub where you can go to the Docker roadmap, and I put a link there for the issue number 91, and that's where they would take input. And if you're curious to get Docker desktop on ARM, put in your feedback there to the Docker team, and they'll know that there are people out there who are interested in Docker desktop on ARM. It'll be up to you if you think you need that or not. I find that the VS Code extension for Docker works very well on WSL2, so combine that with a command line activity seems pretty good, but it's up to you. If you want to back Docker desktop on ARM, please do that. Okay, so what I want to do now is give a little bit of a perspective on why we want to do this. I mean, it's really neat that we have laptops and tablets with ARM processors and the ARM architecture, and we can run them, but why? What's it for? So let's talk a little bit about that. So back before I even started in software development, let's say 1950s, computers were programmed by punching lots of holes in cards. And then we deployed software by punching more holes and more cards. So that's even older than I am. So that gives you some perspective. Now, when I did start back in the 90s, this is kind of how things work. So as the ARM architecture came on the scene and gained traction in all kinds of embedded systems, there were lots of boards with ARM CPUs. And the software development process was to cross-compile software, and then we downloaded it to the boards, and we used utilities like a Telnet and FTP, and then SSH, SCP, and we kind of went around our software development loop, copying files to our board over the network or by USB, and then at some point we froze the software and we programmed a flash or SD card, and that was the software development process. So everything was about cross-compiling and working on our desk with an x86 machine and then moving the software to the ARM target system, whatever that might be. Then along in the 2010s, software development started changing very dramatically. So as the world moved to cloud computing and containers, everything became container-based, and all of the software projects were doing container creation and pulling those containers and scaling those across the cloud. And it was a much different model because the software was packaged in a much different way. Now what we're seeing is this transition where we're going to bring the embedded software development kind of into the future and into the current methodologies that are used today. So what we want to do is get out of the 90s and kind of get up to the current date. And use the ARM architecture as the common platform across all the different types of computing that we need as part of our software development process. So let me show you how that goes. So I'm going to take another flashback a long ways, this time to 2019. So not that long ago, the software developer experience made a big improvement in the container world by rolling out something called multi-architecture images. So what those are is that you can build a single container that'll support multiple architectures. So in practice, what this meant was that if I'm sitting at my desk and I had my x86 laptop, I could create a container for the ARM architecture, and then I could move that container to an ARM machine. Maybe it would be an embedded board or IoT application or an ARM server, and those containers would run seamlessly, which is really nice because now I don't have to do the container building on the native architecture that I'm trying to target. So that was a big improvement. But at the same time, it still was kind of a drawback. I mean, some of the methods used to build these ARM containers were built on instruction translation. Some of the compiling took a long time depending on your application. So it's very application dependent whether or not this multi-architecture image was a good thing or it was kind of a more difficult thing to deal with because of the performance issues. So fast forward to today and things look a lot different. So sitting on my desk now, we have Windows 10 on ARM laptop, and that allows all of those same features of the container-based development flow to work across my laptop and my embedded and IoT boards and ARM servers, right? So with this, we don't have to worry about the multi-architecture containers. We can just build ARM images using the setup that I just went through. A combination of VS Code and WSL2, Linux distributions, and Docker. That's pretty much everything needed. You can build ARM images right on your desk and then again move those to the target systems. So let's talk a little bit more about that. So again, back in the old days, 2019, we had a situation where the multi-architecture containers were good, I would say. I kind of put that in yellow, but the build time caused some issues. So if you had a very large C++ application, maybe a machine learning framework or application, it was hard to work on an x86 machine and build that ARM container. So that was kind of a pain. Of course, cross-compile, we really want to get away from that. It's very difficult in a complex software stack to cross-compile, get all the right libraries and the right dependencies, and then move that environment to a target system. So that's pretty tough. The third one, target build, there you see a lot of people would just resort to trying to build software on their embedded or IoT board. Again, can be done. It's very easy in terms of the complexity, but it's very slow, right? Because the computing power that's made for IoT or edge computing is not the same as what we have on a desktop or a server. So again, that had some drawbacks. So as a result, you know, as we've demonstrated the move to Windows 10 on ARM here, we can really get the best of everything, right? So we can use containers to have a consistent environment. We can build them very fast for the ARM architecture and then deploy to our targets with great results. So hopefully you can kind of see that the software development environment I set up here makes life much better as far as the flow goes. Okay, so what do we end up with? We end up with a situation like this, where by using Windows 10 on ARM, we can have local development with Windows on ARM laptop. You can get all the benefits of the build once, run anywhere concept of containers, and you have the same architecture throughout. So after maybe I do some early development on a laptop, get a container going, then I can decide if, okay, this is a very large job, I'm going to have to compile things for a long time or construct this container. I have some choices, right? So I can move to the right, which would allow us to move to an ARM server. So AWS Graviton and Graviton 2 processors provide the resources to be able to build larger software stacks even faster. So we can get many more CPUs, very large memory, and really blow through and automate the container creation process, even better than the Windows on ARM laptop can do. And then we can deploy those containers to our embedded and IoT boards. So Raspberry Pi, any IoT and edge compute systems which are running Linux and can run containers, we can deploy those there. So you can see these kind of three targets here make it very good for building and running containers and having the ARM architecture consistent throughout the entire experience. So one more tip I want to share here is we get a lot of questions about how to run graphical applications with WSL2. And the way you can do that on Windows is to use RDP. So an RDP client is always built into Windows. And let's say I'm running WSL2 with Ubuntu, I can install the XFCE desktop and XRDP, which will make a connection to RDP client. And then I can bring up a Linux desktop right on my Windows laptop. Again, all with the ARM architecture. So it's pretty neat. Just look in your WSL2 with the ifconfig command, and that'll show the IP address of the machine you want to connect to with your RDP client. So that IP address will change as you start and stop the Linux subsystem on Windows, but just have a look there, and then you can make an RDP connection and get the full Linux desktop. Okay, so the other point I just want to make sure is, yeah, keep that IP address. It's also possible to do this with VNC, but I'm not going to cover that today. Maybe we'll have some other blogs or articles in the future on how to do that, so stay tuned. So a couple other tips to work through here. So often another frequently asked question is, can I use SSH to connect to WSL2? That is possible. So you can install OpenSSH server or other SSH server in Linux, start up that service, and then again, using the IP address of the WSL2 instance, you can connect to it by SSH. So that's helpful sometimes. The other one here is about the backup and restore. So one of the neat things about WSL is you can export a tar file, which will be a backup of your file system. So at any point, you can just quickly take a snapshot of the file system using the WSL-export. So that works really well. And of course, the restore or import will do the inverse. So you can take your backup and restore it using WSL-import. Now, a neat thing about this is the import command can also be used to bring in any new Linux distribution. So you might call that side loading, or if you have Linux file systems that are not available in the Microsoft Store, how can you install those? And this is the way, right? So if I could even construct my own custom Linux file system for my ARM IoT or Edge application, and I can import that right into WSL2, and I can see the full, contents of the file system. I can run the applications, I can compile things, make new applications right on my desktop, and then again, export that file system, take it back to the embedded board, and put it right there. So it makes for a neat loop for software development, being able to bring in any arbitrary Linux file system right into WSL2 with this -- import command. Okay, so in terms of summary for Windows 10 on ARM, I think hopefully you've seen that the laptops that are now available in the market are pretty neat for software developers who are working completely with the ARM architecture in terms of server or edge IoT type projects. So you get that single architecture for all phases of the process. Really, ARM is a first-class citizen everywhere. We can just skip all the multi-architecture containers. We can skip the cross-compiling and all the difficult things that we've gone through for a number of years. You can see the picture for the ARM ecosystem really filling in now. We've got access to ARM compute and all different kinds, and it makes the software developer experience a whole lot better. So I just want to thank everybody for coming today. We have some links to some other developer resources. Definitely check out our developer.arm.com. And have a good rest of the conference. Thank you very much. Okay, thanks everybody for attending the presentation today. We'll just take a few minutes now for the Q&A. So if you have questions, please go ahead and submit those in the question chat box, and I can answer those. Currently, we have one question, which is about the advantages of programming on ARM in contrast to the usual x64. So I guess, there's lots of ways to answer that about ARM versus, other architectures. Certainly one of the things about ARM over the years has been the low power of the architecture and then the broad ecosystem of choice. So, with ARM, you typically are going to have lower power across those devices. You're going to have lots of devices to choose from to meet your particular application. I would say this presentation was really about the consistency of the compute across that embedded IoT on your desktop and in server and cloud. So, historically ARM is very strong in IoT and embedded things, and then we always had to use a different architecture on our desk and in the cloud, and like I mentioned, it's a little hokey and difficult to work with. So really now we have ability to kind of unify the architecture across all those different places where software development is done, and it makes it a lot easier from the developer's perspective to move things back and forth as we work on our desktop, we work in the cloud, and then we work with our IoT and embedded boards. So thanks for that. Okay, let's see if we have any other questions here. Doesn't look like it. So again, I'll just wrap up. So thanks everybody for attending the ARM Dev Summit. Continue to watch the other presentations, and definitely feel free to follow up if you have any more questions about the, we got one more coming in. Okay, just a typo on the last one. That's fine. If you have any more questions, feel free to contact me. Otherwise, enjoy the rest of the conference. Thank you very much.